Hello and thank you for watching my video. My name is Astrid Krasniqi. We'll continue with section 9.2 addressing schemes. And welcome back for you guys who covered section 9.1 subnetting IPv4 address. I know that was a very long video. This is not going to be as long. I'm going to try to not make it as long. Okay, 9.2 addressing schemes talks about planning to address the network. Allocation of network addresses should be planned and documented for the purpose of. First purpose is to prevent duplication of addresses. Each host in an internetwork must have a unique address. Without the proper planning and documentation, an address could be assigned to more than one host, resulting in access issues for both hosts. You've seen these before, like a duplicate address found, and so the host is not able to access the network. Providing and controlling access. Some hosts, such as servers, provide the resources to internal hosts as well as to external hosts. If the addresses is randomly assigned and not well documented, controlling access is more difficult. Now, for example, imagine you have a printer. The printer's address is 172.16.1.10. You set on your computer that address. If the printer gets their address changed often, you're going to have to change on your computer that printer's address all the time. So that's why for those servers and printers, you're going to need a static IP address rather than dynamic IP address. And documentation and planning is for monitoring, security, and performance. As a part of the monitoring process, network traffic is examined for addresses that are generating or receiving excessive packets. If there is a proper planning and documentation of the network addressing, problematic network devices can be easily found. Like, for example, if say we separate our network for host devices, servers, printers, intermediary devices, gateway, and so on. Now, if the host, for example, with IP address .200, it's got excessive packets, we know it's not the servers or printers. We know it's a host device. So we can a bit more easily find the problematic device. A network addressing plan might include using a different range of addresses within each subnet or for each type of device. So each subnet will have a different range for different types of devices. First, we have to think of addresses for clients. Because of the challenges associated with static address management, end user devices often have addresses dynamically assigned using DHCP or Dynamic Host Configuration Protocol. DHCP is generally the preferred method of assigning IP addresses to hosts on a large network because it reduces the burden on the network staff and virtually eliminates entry errors. For example, if you have, say, 2,000 PCs, you don't want to go around and assign a static address to each PC. It's going to take you days. And get the DHCP that will do the job for you. Another benefit of DHCP is that the address is not permanently assigned to a host, but is only leased for a period of time. If we need to change the subnetting scheme of our network, we do not have to statically reassign individual host addresses. With DHCP, we only need to reconfigure the DHCP server within the new subnet information. After this has been done, the hosts only need to automatically renew the IP addresses. Addresses for servers and peripherals. Any network resources, such as servers or printers, should have a static IP address. The client host accesses these resources using the IP address of these devices. Therefore, predictable addresses for each of these servers and peripherals are necessary. Addresses for hosts that are accessible from internet. In most internetworks, only a few devices are accessible by hosts outside and the corporation. For the most part, these devices are usually servers of some types. As with all devices in a network that provide network resources, the IP addresses for these devices should be static. Addresses for intermediary devices. Almost all traffic within or between the network passes through some form of intermediary device. Therefore, these network devices provide an opportune location for network management, monitoring, and security. Okay, that was very nice and short. Now we move to section 9.3, designing consideration for IPv6. Subnetting using subnet ID. An IPv6 address space is not subnetted to conserve addresses. Rather, It's subnetted to support hierarchical logical design of the network. Recall that with IPv6, address block within a /48 prefix has 16 bits for subnet ID. Subnetting using the 16-bit subnet ID yields a possible 65,536 subnets and does not require borrowing any bits from the interface ID or host portion of the address. Each IPv6 /64 subnet contains roughly 18 quintillion addresses, obviously more than we'll ever need in one IP network segment. Subnets created from the subnet ID are easy to represent because there's no conversion to binary required. To determine the next available subnet, just count up in hexadecimals. So here we have purchased, for example, subnet 48 network, /48 prefix, and then we have 16 bits available for subnet IDs. So with this, there's a 16 bits, so each hexadecimal digit represents 4 bits, and 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. So with 16 bits, we can have 65,536 different subnets. So that's more than what we're gonna ever need. Then it's easy to represent. We just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F. When we reach the F, then we go again 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. That's it. But we can subnet into the interface ID as well if we want. Similar to borrowing bits from the host portion of an IPv4 address, with IPv6 bits can be borrowed from the interface ID to create additional IPv6 subnets. When extending the subnet ID by borrowing bits from the interface ID, the best practice is to subnet on a nibble boundary. A nibble is a 4 bits or more or 1 hexadecimal digit. Subnetting on a nibble boundary means only using nibble aligned subnet mask. Starting at /64, the nibble aligned subnet mask will be /68, /72, /76, /80, and other. It is possible to subnet within a nibble boundary, within a hexadecimal digit, but is not recommended or even necessary. For example, if a /66 prefix length is used, the first 2 bits will be part of the subnet ID, and the second 2 bits will be part of the interface ID. Okay, so let me just take this here, what we were doing. For example, you have a network 2001 DB8 ACAD. Now, with this network, you have 16 bits to create your subnet. So, for example, 0000, that's the first subnet, yeah, /64. Okay, now the second subnet will be 001, and the third subnet will be 002, and we will continue like this, until we get, for example, F here, the last one. Then, once we get F, we move to the next one. Sorry, last one for this hex for this hex digit. Then the next one will be 10. We'll start with 10. Then will be 11. 12, and 13, 14, 15, 16, 1A, 1B, until it reaches 1F. 1F. When it reaches 1F, then we go to 20, and it will be 21, 2, and so on. This will have it will give you 65, just over 65,000 different combinations. Okay, now we, for example, say we get in this address. This is our subnet. Say 3F or 3B. We are given. We can even subnet this even further if we want to. But to subnet it even further, we have to actually start using the zeros on the network ID side of it, right? So this one, for example, is like this: /64. It's like this: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's the ID actually represented. Now, if we want to subnet it even further, we can start borrowing these zeros here. But remember that 0 that I got it highlighted is actually hexadecimal digit, which is representing 4 bits. You can borrow those and start subnetting into there. When we start subnetting into there, when we start borrowing this is going to be another 4 bits, so you have to add this 68, which says this one here as well, this bit here is for the part of the subnet. Right. Okay. Here, for example, we have borrowed 1 hexadecimal digit or 4 bits in the network ID, so we can start changing that. I will show you a demonstration subnetting IPv6 and assigning IPv6 addresses. So okay, let's take an example here. Let's take our example, which we have 3B here, and we subnetting into this. So we can subnet it even further. So we can say this. We can say not one subnet can be this 1. The other one can be 2, and then 3. We have it till F, yeah. So we can have 15 different subnets or 16 different subnets. Okay. So let's change this. We're gonna do it on the GNS, yeah. Okay. So if we start the GNS, here we go. The GNS. This is the network that we've been using. Okay, we have changed the IP addresses a little bit. So let's have a look at what we did. 2001 DB8 ACAD 03B 1 2 3 and we need 4 networks here. So 1 2 3. How many networks do we need? 1 2 3 4. Yeah. So let's take this network 1, this network, I don't know, 5, A, and D. I'm just thinking this on the top of my head. So because we have 1 to F, we could use. So this could be 5. This could be our A, network A, and this could be network D. Okay, so this is our network that we're going to be using, right? So let's copy this. Go here. Right. :/68. Right. That's for this network here. This one is going to be IPv6 now, so colon. Copy this here. This one is going to be, what do we say? 5. This one is going to be, we said A. So A. Doesn't matter. Lower letters, upper letters, the same. And then this one is going to be, we said D. Did we say D? Yeah. Okay. Now we're going to start configuring the IP addresses for these network, for these 3 routers, for the PCs. Now you can see that we have actually went in the interface ID. We have borrowed the interface ID, so we're using this hextet as a network ID as well. We don't have to do that because just by 16 bits in subnet portion of it will give us 65,000. But I just wanted for you to see it that you can actually do it on the network ID as well. Okay, so we have to, there's already a startup configuration on all of these routers, yeah? But if you don't remember the startup, you can visit the other pages. I can do it very quickly here. So we have enable, configure terminal. Now, if you, for some reason, you don't remember the startup configuration, you can visit the previous pages. For example, chapter 2. Yeah, visit chapter 2 of this series and it will explain exactly what these commands do. But we have configure terminal, no IP domain lookup, service password encryption. Okay, I'm trying to type lightly so it doesn't make too much noise when you hear me. Service password encryption. No IP domain lookup, enable secret class, and banner MOTD authorized users only, and then we have to close the banner with whatever we opened with. Host name I'm not going to change because they all have the correctly configured. Line console 0. password Cisco. If you put, for example, spaces, this is your part of the password, yeah. So make sure that when you put the password, there's no spaces, trailing spaces. Leading spaces is fine. It's not going to take effect until it sees a character. Then that will be part of the password. With trailing spaces, make sure there's none. Password Cisco, unless you want it. Login sync, exec timeout 00, line VTY 0 to 4, password Cisco, login, and exit. Okay, I will highlight all of this and then copy and paste it to my routers. This is already done to all 3 routers, so they all have the startup configuration, but just so you can see it. Okay, here I can see there's a problem here. I misspelled enable, so for the next configuration I'll go and fix that. So that's why it's good to do the notepad. So enable secret class. Okay, sorry, here we go. Copy again, right click, copy, make some space here, paste it, and yeah, we didn't need to do configure terminal there, but the rest of the commands seems to be fine. Okay, so router 2, we go and paste the same commands. So I'll go to router 2, Cisco, right click. Yep, now everything is working, all the commands are fine. And router 3, I will go to router 3 now. No, I don't want to disconnect. Cisco, and paste it to router 3. Okay, now what I'm going to do is I'm going to start configuring my IPv6 addresses. So if I open my GNS so I can see it, router 1 has got 2 interfaces. One that is interface FA00 towards the local LAN, sorry, and the serial interface towards the rest of the network. First, I need to enable IPv6 unicast routing. Unicast routing. Right, so I'll go to the interface FA00, IPv6 address 2001 DB8 ACAD 003B 100 double colon 1 for router 1 /68. Yep. I'll do a link local address as well, IPv6 address FE80 ::1 and say link local. Remember, link local addresses, they don't exit the link, they stay within the link, so they don't go to the rest of the network. So you can give the same address to all the interfaces to identify that it's router 1. Okay, the second interface is serial interface, so interface S10 S/1/0 IPv6 address 2001 DB8 ACAD 003B. This one we said is going to be 5, I think. Yep, 5000 ::1 /68, and I can copy the link local address. It's 500 because we have up to here is the network ID. This is the network ID. This one is part of the host ID. So it's 5000. We can't take away the trailing zeros. We can remove the leading zeros. So like this, we don't have to type 003B. We can just type 3B. But the trailing zeros, we have to leave them. Okay, that's your router 1. Router 2 has got 2 interfaces. So let me just copy the unicast routing. Interface S10, that's towards router 1, IPv6 address 2001 DB8 ACAD. Now I'm going to remove the leading zero, so just 3B :5000 ::2. This is for router 2 68, and link local IPv6 address FE80 ::2, and this is linked local. Right, so I'm going to copy this, similar for serial 11, which towards router 3, And we said here this is gonna be A, yeah? A. That's it. And link local is the same. So I'm gonna do for router 3 as well. Router 3. Router 3's got two interfaces, one serial and one local LAN. So interface serial 11, that is towards router 2. And I'm gonna just copy router 2 because then I'll just change what needs to be changed. This one needs to be changed to 3, represents router 3, and this one needs to be changed to router 3, represents router 3. Then I say interface FA00. I just do the unicast routing, so don't forget that as well. Unicast routing. Interface FA00, IPv6 address 2021 DB8 ACAD colon 3B, and this we said is D gonna be, yeah? Yeah. Hold on. D, yeah. Okay, so D000 colon 3 and /68, and the link local I can just copy it. Okay, now the router's IP addresses are configured, so I'm just gonna copy them and paste them to the correct router. So router 1, highlight all this, right click, copy, go to router 1 and paste it. Excellent. Now I'm going to do the router 2's IP address, copy, go to router 2, paste it. Okay, and now I'm going to do the router 3 as well. So router 3's address, copy this side, copy and paste. Okay. Okay, now we do for router 1. It says default route IPv6 route anything with any prefix, send it out of serial 10. Okay, we do the similar for R3. So it says IPv6 route any network with any prefix, send it out of serial 11. Okay, so I'll copy this to router 1, go to router 1, paste. Then I'll do the same for router 3, copy the router 3 config, copy that, go to router 3 and paste it. Then I'm going to do for router 2, that says router 2 IPv6 route anything you're going to router 1 local area network 2001 DB8 ACAD colon 3B 1000 colon 68. I want to send it out of S10. And now anything that goes to router 3 local area network 2001 DB8 ACAD 3B D000 colon 68. I want to send it out of serial 1/1. Copy all those two, go to router 2 and paste it. PCA and PCB, start configuring, and we should have some IPv6 communications. So for that I'm going to use my virtual machine that we've been using it for our exercises now, PCA and PCB. So file, okay, we got PCA there. So power this virtual machine, and I'm going to power PCB as well. Okay, the machine is starting to struggle a little bit, but I think it will cope. Okay, there we have. Okay, I'm going to pause the video until this boots, so you don't have to wait until they start. Okay, after a couple of minutes, PCA is ready, PCB I think is still just about getting ready. Okay, so we're going to go to PCA and start configuring. So we open the control panel. It was a bit slow, so I think the computer is starting to struggle a little bit. Control panel. Okay, network and internet. Network and sharing. Local area connection. And then properties of that. Now we're going to select IPv6 configuration. Okay. TCP IPv6, properties of that, and then we're going to use the following IP address. The IP address for this was 2001 DB8 ACAD 3B 1000 colon I think this was A, so we can go and check it. 2001 DB8 ACAD 003B 1000 colon A, yes, /68. So if I go to that, say / this is 68. The gateway is 2001 DB8 ACAD 3B 1000 colon 1. Done. Okay, close that and close the local area. So go to PCB and do similar configuration. Okay, we're gonna restart later. Work network. So start the control panel. Network and internet. Network and sharing center. Local area connection. Properties of that. And we're gonna select IPv6. And statically we're going to configure to 2001 DB8 ACAD 3B, and for this was D000 colon and this was B. Okay, so B and is prefix 68. The gateway is 2001 DB8 ACAD 3B D000 and colon 3. Okay, close that. Right. Okay, if we did configuration correctly, everything should be working now fine. PCA should be able to ping PCB on the address, on the IPv6 address that we have configured. So if I go to PCA again and try and ping, you can see that I can ping the gateway, so I should be able to ping the PCB, which is address 2001 DB8 ACAD 3B, it was D000 colon B for PCB, and yes, we do have a reply. Thank you very much. Yeah, this showed very well that we can configure an IPv6 address and then start even subnetting it more on the interface ID. Okay, that shows the demonstration for you, and thank you for watching my video. I know it's been very long with this, especially 9.1. Please have a look at other videos and don't forget to subscribe. This has been Astrid Krasniqi. Thank you and goodbye.